Let's begin Chapter 5, Lesson 4, Polygons and Angles. Again, let's take a look at our essential question. How can algebraic concepts be applied to geometry? By now, you've probably figured out that even though we're talking about geometry, we're solving lots of algebraic equations in order to get our answers. Our vocabulary for Lesson 4 is polygon, equiangular, and regular polygon. Our Common Core State Standard is going to be an extension of 8.G.5, which means it's not exactly 8.G.5, but something that we're going to learn from that standard. And then we have mathematical practices 1, 3, and 4. Let's take a look down at the bottom. 1 is persevere with problems, 3, construct an argument, and 4, model with mathematics. So let's go back up to the top and see our vocabulary. It says a polygon is a simple closed figure formed by 3 or more segments. The segments intersect only at their endpoints. Sounds a lot more difficult than it is, but let's go ahead and turn to page 398 and take a look at our key concept. So our first key concept in Lesson 4 is interior angle sum of a polygon. So we've already talked about the interior angles of a triangle, and we know that the interior angles of a triangle equal 180 degrees. While a triangle is a polygon, there are lots of other figures that are polygons too, because anything with 3 or more sides is considered a polygon. So let's look at the interior angle sum of a polygon. The sum of the measures of the interior angles of a polygon is n minus 2 times 180, where n represents the number of sides. So our equation would be S equals n minus 2 times 180. You can use the sum of the angle measures of a triangle to find the sum of the interior angle measures of various polygons. A polygon that is equilateral, meaning all sides are the same length, and equiangular, meaning all angles have the same measures, is called a regular polygon. That's going to be really important for us to know. In order to do most of the things that we are going to do in this section, we need to know whether or not the polygon is regular. So we have to be able to determine whether all sides are the same length and all angles have the same measure before we can use this formula. So let's take a look at this figure in the middle. Number of sides, 3. We know that that is a triangle. The number of triangles formed is 1, so 1 times 180 equals 180. If the number of sides is 4, we could divide that into 2 triangles, so 2 times 180 equals 360. If the number of sides is 5, we can divide that into 3 triangles. 3 times 180 is 540, and if the number of sides is 6, we can divide that into 4 triangles. 4 times 180 equals 72. Let's take a look down at the example 1 at the bottom. It says find the sum of the measures of the interior angles of a decagon. Well, the first thing we have to know is this word right here. And we should know that deca means 10. So that means we've got decagon, which means sides. We've got 10, a 10-sided figure. Think of the word decade, which means 10 years. So we're going to take our formula, S equals the difference of n minus 2 times 180, and we're going to fill in what we know. Remember that n equals the number of sides. Write that over here if we need to remember that. So we know the number of sides is 10, so S equals the difference of 10 minus 2 times 180. 10 minus 2 is 8, times 180 is 1,440. So now we know that the sum of the measures of the interior angles of a decagon is 1,440 degrees. So the sum of the measures of the interior angles of a triangle, 180. But if you have a 10-sided figure rather than a 3-sided figure, then the sum of the measures of those interior angles is going to be 1,440 degrees. So let's take a look at the examples below. We've got hexagon. Remember that Hex means we have six-sided figures, so we're going to take S equals n minus 2 times 180. S equals 6 minus 2 times 180. S equals 4 times 180. And 4 times 180 is going to be 720. So the interior angle measures of each polygon, in this case a hexagon, is going to be 720 degrees for a hexagon. Example B, we're talking about an octagon, and we should know that octa means 8. So we have S equals, notice that I'm writing my equation formula each time. That helps me to learn it. So S equals the difference of n minus 2 times 180. N is the number of sides, in this case 8. S equals 8 minus 2 is 6 times 180. And 6 times 180 is going to be 1,080 degrees. So if we're looking at the sum of the measures of the interior angles of an octagon, it's going to be 1,080 degrees. All right, in C we have a 15-gon. Sometimes they have names, sometimes they don't. Sometimes even if they do, they don't use them. So 15-gon means we have 15 sides, so S equals the difference of n minus 2 times 180. N is the number of sides, so we're going to put 15 minus 2 times 180. S equals 13 times 180, and 13 times 180 is going to be 2,340 degrees. So for a 15-gon, we'd have 2,340 degrees. Remember, you need to use your degree symbol when doing these. All right, let's take a look at page 399. Example 2, it says each chamber of a bee honeycomb is a regular hexagon. Now remember, it's important that we know it's regular, meaning it has sides of the same length, angles of the same measure. Hexagon we know means 6 sides. Find the measure of an interior angle. That's going to be important because it wants to know the measure of just one of those angles, not all of them, because we figured out that all of them equal 720 degrees. We figured that out just a minute ago. So this is what we did to find that out. We took S equals the difference of n minus 2 times 180. We substituted 6 for n. We got S equals 4 times 180, or 720 degrees. So we figured that out in our examples on the previous page. So now we know the sum of the measures of the interior angles is 720. So what we're going to do then, we know that there are 6 sides, meaning there are also 6 angles. So we're going to take that 720 and divide it by 6, and we're going to get 120 degrees. So this is the way I write the formula for one interior angle. Let's write it over here. If I want to find one interior angle, I'm going to write it S equals the difference of n minus 2 times 180 divided by n. So let's take a look at the examples. For example D, we've got octagon. Well, we've already figured that one out, but let's do it again. We've got 8. We're going to take S equals n minus 2 times 180 and divide it by n. Okay? So let's go ahead and show our work over here. We have S equals 8 minus 2 times 180 divided by 8. S equals 6 times 180 divided by 8. We already said that 6 times 180 is going to be 1,080, and we're going to divide it by 8. And 1,080 divided by 8 is 135 degrees. So one angle, just one of the interior angles of an octagon is 135 degrees. If I add all 8 of them up, it's 1,080 degrees. Let's take a look at E and F. We're not going to work each one of those out, but let's look at the prefixes. We've got heptagon, which means 7-sided, and then we've got 20gon, which is obviously 20-sided. If you have a few minutes, it might be helpful for you to work those out on a piece of paper or somewhere on this sheet if there's some space, in order to practice and make sure you understand how to use the formula to find that answer. Let's go on to the next key concept. The next key concept is exterior angles of a polygon. So we've talked about the exterior angles of a triangle in the last section, and we said that we had to add the two remote interior angles to get the exterior angle. Well, it's a little bit easier, I think, here for a polygon. So in a polygon, the sum of the measures of the exterior angles, one at each vertex, is 360. That goes for the triangle as well, because if you add all three of them up, you're going to get 360 degrees, no matter whether it's a triangle, quadrilateral, pentagon, hexagon, heptagon, octagon, nonagon, decagon, doesn't matter. So we've got, in the model, we've got exterior angles 1, 2, 3, 4, and 5. When we add all 5 of those angles, we're always going to get 360. So there's really no work to do there. So it says, regardless of the number of sides in a polygon, the sum of the exterior angle measures is equal to 360. So here we have a 3-sided polygon, which is a triangle. Add those 3 together, you're going to get 360. We have a 4-sided polygon, which is a quadrilateral. When we add all 4 of those together, we're going to get 360. Does not matter what their sizes are, anything, doesn't matter what they look like, the exterior angles are always going to equal 360. Let's turn to page 400. On page 400 at the top, we've got example 3. It says, find the measure of an exterior angle in a regular hexagon. Now remember, it's important when we're talking about these things that we understand whether it's regular or not. It says let x represent the measure of each exterior angle. All right, so if we have a hexagon, we know we have 6 sides, so we would actually have x plus x plus x plus x plus x plus x equals 360. That's how we got 6x. So we added all of those up, all of our like terms. 6x equals 360. Divide by 6, and we get x equals 60 degrees. So look at we're finding not all of the sum of all of them, but just one of them. So in order to find one, we have to divide 360 by the number of sides. So if we were looking to find an exterior angle, remember an means one, just one angle, on a triangle, we're going to take 360 and we're going to divide it by the number of sides. Remember, n equals sides, so we got 360 divided by 3 because a triangle has 3 sides, so we're going to have 120 degrees. Quadrilateral means 4. Quad is 4. So we're going to take 360, divide it by the number of sides. 360 divided by 4 equals 90 degrees. And then we have octagon, which we know means 8. So we've got 360 divided by 8. And when we divide 360 by 8, we get 45 degrees. So an octagon, just one interior or exterior angle of an octagon equals 45 degrees. One exterior angle of a quadrilateral equals 90 degrees, and one exterior angle of a triangle equals 120 degrees. Now that you're finished, if you would feel more comfortable going back and reviewing the video one more time without having to do the writing so that you can just listen and follow along, that would probably be very helpful. If you feel comfortable with it, you can go ahead and bring your book in for your lesson tomorrow. No homework tonight. We'll do the guided practice together in class tomorrow. So just bring this with you and we'll work together on it.